Welcome back. Right, vasculature. So, we're going to talk about the arterial, the venous, and the sinuses, the dural venous sinuses. So, remember that your arterial circulation is divided anteroposteriorly. Your anterior circulation is internal carotid based. Your posterior circulation is vertebral arteries uniting to form the basilar artery that forms all of the posterior circulation of the brain. Okay? So, the circle of Willis, bread and butter neuroanatomy stuff here. We'll very briefly go over some of the key constituents. First of all, let's landmark ourselves. So this is an inferior of the brain. We have the temporal lobe around here. We've got the mammillary bodies here. We've got the pituitary stalk, the infundibulum. Okay, we've got the wonderful pons there. So we have the cerebral peduncles here and here. Now, optic chiasm, optic nerves, optic tracts behind. Here's our curling internal carotid, which is on its way to terminate into this middle cerebral artery here. Just before it does, it gives off a posterior communicating artery, and it gives off this artery here. This artery here. This is our anterior choroidal artery. Okay? In part because it forms the choroid plexus of this temporal lobe region here. Yeah? Which is intimately related with the hippocampus apparatus around here in the ventricular system. So anterior choroidal artery, then a posterior choroidal artery will unite later. But this is basically the main things you need to know. So, internal carotid, middle cerebral, anterior choroidal, posterior communicating. Here's our basilar giving off pontine branches, variably named, but then bifurcating here and here, just before it reaches the interpeduncular fossa, into the posterior cerebral artery. So posterior communicating, posterior cerebral artery. Third nerve comes out around here, so PCOM aneurysms, posterior communicating artery aneurysms that occur at the junction with PCA and PCOM, a very common site of berry aneurysms, which we'll come to, little saccular aneurysms. These are common site and causes of third nerve palsies, isolated third nerve palsies. So middle cerebral. Here we have the anterior cerebral artery, right, with the anterior communicating artery between it. And note first nerve's tract here, the olfactory tract. So this is a whole sequence of anatomy that you just need to be comfortable with. So that's where the anterior and posterior circulation join. So here's a beautiful illustration of the anterior cerebral artery, which is here. And if we carry on the picture mid-sagittally, it runs along here and follows the corpus callosum. So here's the corpus callosum. So this region, the end of the anterior cerebral artery, is called the pericallosal branch. Okay, the pericallosal artery. But it does split into this orbitofrontal artery, so the orbital frontal gyrus, it reaches this region here, and then this region that sort of sits on the border, this upper border of the cingulate gyrus. So here's our cingulate gyrus, and then here, on the marginal sulcus of it, is this branch here called the callosomarginal artery. So we have a pericallosal, and then we have a callosomarginal. And this callosomarginal sends up branches all the way up here, and then they wrap around on the top and to the superior most medial portion of the the superior bit of the lateral surface of the cerebral cortex. So all of these regions, the paracentral lobules, the superior frontal gyrus and the like, they're all being supplied, and the somatosensory cortex, so the medial most homunculus, motor and sensory, is being mostly supplied by the callosomarginal arteries. The only other branch to mention here is the polar frontal artery. So that's ACA, orbitofrontal, polar frontal, callosomarginal, and pericallosal artery. Just mention PCA while we're here. It gives off a few branches that are variably named, but the calcarine artery is one such artery that it gives off. That's really important. So that runs to the calcarine sulcus, and that's the vasculature for V1, V2, V3, and the like. So, key ones to note about ACA: medial striate, which is the anterior cerebral artery's penetrating branches, which supplies the caudate nucleus and the like, and a little bit variably of the anterior limb of the internal capsule. Your orbitofrontal branch here, your polar frontal branch, your pericallosal branch, and your colloso-marginal branch. Cool. So here it is again. So we'll just see, this is a brilliant one. So we can see the internal carotid, and it has a few different areas where it comes and it curls back on itself characteristically, forms the MCA, forms a few other branches here, but this is the one that we care about. So the anterior cerebral artery giving off, well, we know it gives off an orbitofrontal here. We know that it gives off a colloso-marginal running along here. We know it gives off a pericallosal, and we know it gives off a frontopolar branch. Now, if we go to the lateral aspect of the brain, find the sylvian fissure, and we can see that there are upper and lower division branches of MCA. So the final portion of MCA is coming out here, and it's supplying this region here. Note that the marginal branches of ACA are sneaking over from that medial aspect to just grab the top here. And the posterior ones are sneaking over to grab this here. So the MCA covers most of the lateral hemispheres, but not all of it. So we have branches to the prefrontal region, we have branches to the precentral region, we have a central region, a postcentral region, and then a parietal one. Following it along, we have an angular region, we have a temporo-occipital region, and a middle temporal region. We can also include an anterior temporal region, and middle cerebral, orbitofrontal as well down here. But these are very variable and hard to see, so they're very rarely named. But there's some key ones to know, like prefrontal, precentral, central, postcentral, angular, following the angular gyrus for part of its course. These are the key ones to know. So just making you aware here that the middle cerebral artery gives off lateral perforating branches, and the MCA piece supplies this lentiform nucleus, the external, claustrum, extreme capsule, a little bit of the insula as well, and quite a portion of the anterior limb of the internal capsule here. Okay, this is the territory of the lateral striate. Sorry, I said that it supplies the insula. It doesn't supply the insula. So it supplies most of the lentiform. But MCA's entire territory includes this whole region. So that's your anterior circulation. Now the posterior circulation that we talked about. So here's our circle of Willis. Here's ICA, MCA coming off, posterior communicating artery with PCA, and the little bit of the basilar left here. So here's PCA, it wraps around the cerebral peduncle here, PCA for peduncle, and moves posteriorly along here. But it gives off a series of branches. It gives off a lateral branch here that provides various temporal arteries, the occipitotemporal artery, so this is to the fusiform cortex, so think about prosopagnosia here, as well as this medial branch that will eventually become the calcarine artery. So the PCA is going to form a lateral branch, the temporal region, and the occipital region more laterally, and a medial branch forming the calcarine artery. If you're interested, we have the visual pathway here, which has a whole amount of blood supply that's worth noting, right? A whole amount of blood supply. So optic nerve, optic chiasm, optic tract, radiations into the calcarine region here, the visual cortex. So see if you can relate this schematic. So here, for example, is the basilar artery, the posterior cerebral artery coming off, giving off posterior communicating artery to the middle cerebral artery along here. And the posterior cerebral, we know, at the end of the cerebral peduncle most laterally, gives off a lateral branch, and it gives off a medial branch. And this medial branch forms the calcarine artery around here. So this is quite a good schematic. This is from the Crash Course series. If it helps you, it helps you. And again, we've already discussed the posterior circulation. Just be aware that there are temporal branches, there's an occipital branch, and then from this medial region, there's the calcarine branch. So if you remember, there's a few branches coming from the lateral portion and from the medial portion, and it wraps around the midbrain here. How do we know this is the midbrain? Because we have periaqueductal grey, we've got the very thin cerebral aqueduct, we've got the cerebellar colliculi, we've got the colliculi of the corpora quadrigemina, we've got the substantia nigra, we've got the cerebral peduncles, the red nucleus, we've got mammillary bodies in the stalk here. So this is another schematic that's quite nice. So this is a more ventral view. So we have our basilar artery here. We've got our vertebral arteries. We've got the anterior spinal artery here. At the basilar artery here, we have Aica given off. So see the cerebellum lecture for that bit. And then at the base of the vertebral arteries, we have Pica underneath. And then of course, we have our superior cerebellar artery at the top of the basilar artery. So this is a schematic that you absolutely should know. And that's the same thing again. Here's what it looks like in an angio. So again, vertebral artery coming in, and then it runs up here. And actually, this is the basilar artery here. At the very top, we get a rapid turn for PCA as it joins the circle of Willis, and it gives off a whole array of arteries. But here's Pica at the base of the cerebellum along there. That's actually a really good Pica for spotting there. And the vertebral artery, just remember, comes through the foramen magnum. The very back, so if this is the cerebellum, you need to think that here is cerebral cortex. This region here, the calcarine artery going to the calcarine sulcus. So, that's a lot of vasculature. So what about the cerebral veins? Well, these are much simpler because they're so variable. So actually just memorizing them is not particularly useful. They branch into external or superficial cerebral veins and internal cerebral veins, right? So we cover the external and we cover the internal. Now these external or superficial veins, there's a couple of them to know. You have the superior cerebral vein. Okay, this is the superior cerebral vein. It drains the superior portion of the cerebrum externally into the superior sagittal sinus. The middle cerebral vein, and then the inferior cerebral vein. Oh, I need to put my laptop on charge now. So, yeah, the middle cerebral vein drains the lateral regions, mostly that Sylvian fissure, into the cavernous sinus for the most part. Palpatine. Oh god, I can't get away from Star Wars, can I? And the inferior cerebral veins. So these drain to the cavernous and transverse sinuses. Okay, so we're going to do the sagittal sinuses in a minute, but those are the sinuses into which they mostly drain into. Trollin's vein is an interesting one because this is an anastomosis between the superior and the middle cerebral vein, and it helps to be, it's basically a collateral circulation. It's what you wish you had in the coronary circulation if your LAD and Pica don't anastomose the apex. It's what you sort of wish you had. This is Trollin's vein, connecting these two together, so there's a secondary supply. And these are the superficial veins. They're draining the superficial cerebral cortex. They're not doing subcortical structures, they're doing those structures. Your internal cerebral veins are very minute. They're all over the place. They're mostly a capillary-like plexus. But here is one you need to know, Galen's vein. And it goes subcallosal. So it's under the corpus callosum, and then it runs down here to join a network of stuff that runs on the tentorium cerebelli, which is here. Okay? So this is Galen, very famous anatomist who came up with the four humours and things like that. But here's his vein, the vein of Galen. So it's coming from this subcorpus callosum region here. The vein of Galen joins the straight sinus to hit this hierophilian confluence, it's called, so the confluence of the sinuses. So, vein of Galen, straight sinus, confluence. And the straight sinus forms a confluence when the superior sagittal sinus meets it. Okay? So that's worth pointing at. So Galen plus inferior sagittal sinus equals straight sinus. straight sinus plus superior sagittal sinus equals confluence of the sinus. So now we come to the dural venous sinuses. So here's your Galen's vein, here's your tentorium cerebelli, and here is your falx cerebri. Now, on the superior aspect of the falx cerebri is the superior sagittal sinus. On the inferior aspect is the inferior sagittal sinus. Remember we said inferior sagittal plus Galen's vein forms straight sinus, and superior sagittal plus straight sinus forms transverse sinus. So this transverse sinus, and I think this is an absolutely beautiful picture because it really just covers everything. The confluence of the sinus receives straight, superior, and the occipital sinus. All of these come together at that internal occipital protuberance, the little bump, to form the confluence of the sinuses, the Hierophilin confluence. They then form the transverse sinus, which wiggles in a sigmoid S-like shape to drop through the jugular foramen to form the internal jugular veins. So the external, and remember that we said the superior cerebral vein empties into the superior sagittal sinus, and the middle and inferior mostly empty into the cavernous sinus down here. They also empty into the sphenoparietal sinus, but more so into the cavernous sinus. So all of those external veins drain in there. The internal veins mostly drain into either of those structures variably or through the vein of Galen into the straight sinus. So this is how this all connects. So let's say I'm the top of the superior frontal gyrus, the cerebral cortex, and I drain my deoxygenated blood into the superior cerebral vein. Okay, it goes through the superior cerebral vein. Maybe it goes through Trollens and anastomosis that we talked about before. Goes through that and empties via the middle cerebral vein into the cavernous sinus, or even into the sphenoparietal sinus. So this is on the top of the sphenoid bone here. It runs into the cavernous sinus, and then it has a few options. It can either go via the superior petrosal sinus to the transverse sinus, or via the inferior petrosal sinus into the portion where the sphygmoid sinus drops into the internal jugular vein. So it can go superior petrosal into the transverse sinus, or inferior petrosal into the sigmoid sinus. This is the arrangement you need to know. You don't need to know a word more than this beautiful illustration here. So try and draw this out from memory if you can. Superior sagittal plus straight plus occipital gives us this confluence. The transverse sinus receives the confluence and receives the cavernous sinus. It then forms a sigmoid sinus, an S shape, and then drops down once it receives the inferior petrosal sinus, which runs bilaterally to this region here of occipital bone, which is called the clevus, which runs up to the cavernous sinus. Okay? So, superior sagittal sinus, superior to the falx cerebri, and drains into the confluence of the sinus. The inferior is inferior to the falx cerebri and drains into the straight sinus. Our cavernous sinus is a bilateral structure that communicates with each other to the sella turcica and drains into the transverse sinus via the superior petrosal sinus or the sigmoid sinus. And it receives the sphenoparietal sinus. Both the sphenoparietal sinus and the cavernous sinus receive the middle and inferior external cerebral veins. Okay? And here's just a little bit more information just so you can sort of orient yourself when it comes to the cavernous sinus. So the cavernous sinus is here bilaterally. Here's the dural venous plexus that's coming up from the spinal cord. So this is how Mets get into the brain case. But you're going to have the confluence of the sinus back here. You've got your transverse sinus here and here, forming a sigmoid sinus, and then your internal jugular vein. So because you know that this is the sigmoid sinus, this therefore is your inferior petrosal sinus, and this region will be your superior petrosal sinus. Cavernous sinus, which bilaterally communicates about the pituitary gland here. So the optic stalk, the infundibular stalk is sort of around it there. Okay? Here's your superior petrosal sinus draining into the transverse sinus, and here's your inferior petrosal sinus draining into either the internal jugular vein directly or into the sphygmoid sinus. And that's it. That's all you need to know. A little recap of the cavernous sinus there. So just remember the different cranial nerves in the lateral wall, and sixth nerve tends to be a little bit more underneath the internal carotid artery. So cavernous portions of the internal carotid artery having an aneurysm will cause a sixth nerve palsy. The aneurysm continues to grow and then it hits this wall. And that's when you get third, fourth, and fifth palsies as well. But sixth is usually first because it's sat there on its own. So here's a little quick recap. See if you can go through the cavernous sinus, see if you can find the superior, the inferior petrosal, see if you can find the confluence and the superior sagittal sinus, see if you can find Galen's vein, which is also called the great cerebral vein, the straight sinus, all those different structures.